Right. So, and I told you guys that like in the short term, that's essentially how it works, but in the long term, it doesn't work like that at all because there's all these factors that control the growth of cats, like predators in the environment and how much food is in the environment. There's all these things that control exactly how many cats you can have, not just how many cats can get down with how many other cats. So,
pumping out babies, man.
right. And so, you know, and rabbits too. So like in the long term, growth of any species. You what? Why are who like what? Like what? Because it's a biological imperative. Why are teenagers the way that you guys are?
Well, there's so many different types of teenagers. You got to be more specific there, Mr. Cat.
I'm just saying. I'm just saying. Okay. So in the short term, the growth of any one species or any one population can be seen as exponential. But in the long term, there are always factors that cap out the amount of growth that you can have. So you can have, like, you can introduce cats to a population and you can have the growth explode, but then there's always going to be some factor that caps it out at some, what's called carrying capacity. There's always going to be some factor in the environment that keeps it from growing past any certain number. I was about to say, the one exception in our natural world seems to be rabbits in Australia. Did you guys know about this?
Yeah, the fence.
The fence that failed.
Well, yeah, so rabbits aren't native to Australia. Australia was a prison colony established in the 1700s, or 1600s maybe even earlier. The governor of Australia, his wife, wanted to establish a traditional English garden, and traditional English gardens have rabbits. So the governor of Australia, his wife, brought a single pair of rabbits over. I want to say it was in the late 1600s or early 1700s. I could be wrong. And that single pair of rabbits has created a population of rabbits that now outnumbers the people in Australia something like 8 to 1. The number of rabbits in Australia is insane. There's no natural predators to rabbits in Australia, and they destroy everything they come across. There are, but not rabbits. Nothing wants to eat rabbits. So what Australia did is this giant continent, Australia built 2 fences to essentially wall off the continent and be like, okay, rabbits, you can have this half of our continent. Let us have this half. And that didn't work, so they built another continent-wide fence and were like, okay, fine, we'll give you that half and this part. Just give us this part. And that still didn't work. It's called the rabbit-proof fence. If you Google it, rabbit-proof fence. Okay.
I have a question.
Yeah. There's a public bounty for rabbits in Australia. Like if you kill, I know. If you kill a rabbit and bring it like to a public justice, they'll pay you for it.
Oh God.
Let's go to Australia with some.
They cannot they can't get rid of the rabbits fast enough.
That's not a very good fence. No wonder it didn't work.
Okay. Anyway, Kim.
No, why don't they release some predators that take rabbits?
Because that would make things worse. Okay, first of all, this whole problem came because rabbits aren't native to Australia. If they introduce a predator also not native to Australia to get rid of the first species not native to Australia, that's going to make the ecosystem worse.
Okay, so none of the native inhabitants.
It's the same problem that we have in America with cats. So
It's not a problem.
it is actually.
How about the Burmese pythons?
So like in America, in North America, cats are responsible for the death of, I want to say, something like 2 billion songbirds a year. The average house cat kills 4 songbirds a week. And house cats are one of the, like, people talk about how like man is the only species that kills for fun. We're not. House cats do it. House cats kill when they're full. They kill for sport. Like, house cats are vicious. They're psychopathic
What
animals.
about the Burmese pythons?
That too. So like there's a huge there's a problem with pythons in Florida, like invasive
Horses
species.
aren't even native to America.
No, not really. Okay, anyway, back to this. So logistic growth. Okay,
You look at the bison, which are.
I know. Let's talk about this. Okay, so I'm going to give you guys a formula here. All right, y prime is equal to k times in parentheses capital M minus y, close parentheses. K is a constant. I know this is less interesting than rabbit's eggs.
Or the rabbit-proof fence.
Or the rabbit-proof fence that Australia was essentially like rabbits. You can have more than half of our continent. Just please give us part of it. That's the rabbit-proof fence in places goes like 4 feet underground.
Okay, then how do they get past the fence?
Well, according to, like they can't maintain it. In places the rabbit-proof fence has been destroyed, and Australia isn't a super rich country, so they can't pay to have people maintain the entire fence that spans an entire continent.
Good point.
Okay, anyway, back to this. So this is an equation that we're going to be using for logistic growth. So let's say that a company estimates.
Can I check the numbers?
Sure.
Hold on.
So here's what's happening. Well, let me lay down some groundwork here so that you can at least not just randomly pick numbers. Okay?
Okay.
A company is no, it's not from your homework. No.
Why would I do that?
Okay, so a company estimates that it can sell 200,000 cell phones. No, 200,000 cell phones in a given area. After 1 month. No. After 1 month. No, one. They've sold 20,000. We want to know how many they can sell after 9 months. How many after 9 months? After 9 months. And so this is, we're going to assume that this is an example of a logistic growth model, because we're going to say that we're only going to possibly be able to put 200,000 of this cell phone in people's hands because people just like their iPhones too much, that we're only going to possibly be able to get 200,000 of this bargain brand phone out there, right? Because people like other phones too much for us to get this phone out into the market. So we're going to try and push, and after 1 month we sold 20,000, we want to estimate about how many we're going to sell after 9 months. Does that make sense? So we're going to use this logistic growth model equation that we just created up here. We're going to say y prime is equal to k, which is a constant that we don't know. And this is going to, you guys are going to love this because this is going to be an equation that ends up with 2 different constants. We're going to have both k and c. I know, you're going to love it. You're going to love it. In parentheses, no, they don't. They super don't. They super don't. And then in parentheses, we're going to have our maximum amount that we can sell, which is 200,000. I'm going to leave it as 200, and then I'm just going to have to remember that my answer when I get to this is going to be in thousands. Because I don't want to have all those zeros fumbling around in here.
That's just gonna
Okay, then you can write it out as 200,000. I'm going to leave mine as 200. You do you. That's fine. And then minus y, close parentheses. All right, so now I'm just following our steps for differential equations. So I replace y prime with dy dx. So this is dy dx equal to k times 200 minus y. And now I have to get all the y's on one side and all the x's and dx's on one side. So I'm going to divide both sides by 200 minus y. I'm going to multiply both sides by dx. So on the left-hand side, I have dy over 200 minus y. And on the right-hand side, I have k which is just a constant. It's like 235 or 78 times dx. Okay? At this point, u substitution to the rescue. All right? So I'm going to have to say that u is equal to 2 hundo minus y. And then that would mean that du is equal to what? So, close. Negative 1 dy. Because the 200 goes away if you differentiate this. The y goes away, but the negative 1, the coefficient, is still there. And then dy comes down too. Kind of, sort of? Right, and so I just have plain dy in my equation, so I'm going to multiply both sides by negative 1, and this becomes negative 1 du is equal to plain dy, so that I can substitute negative 1 du in place of dy. Kind of, sort of? So far, if you're trying to keep track, the only number you need to change, Ms. Wiggum, is 1. You only need to change one number to do your assignment so far. You tricksy minx. So we're gonna. So we're going to do the integral of both sides, and so the integral of the left-hand side. This is going to be negative 1 u to the negative 1 power du. I'm just going to rewrite it so it's easier for me to see it. And then on the right-hand side, the integral of k dx ends up just being kx plus c. I'm just going to jump right ahead with that. Because k is just a constant, even though I don't know what it is, I can still jump ahead with it. And now I have two constants.
You integral the right, not the left.
Right, I didn't integral the left yet because I had to do that u substitution. Do I not what? Awesome.
I was just wondering if you knew that the lines were on the paper for a reason or not. I was just wondering if you knew.
I do, but if I put this...
I just kind of find it interesting how you
Don't use the line.
don't
Write
respect
it
the
down.
lines.
If I put this on the line, it would be too jammed up against that y.
There's space there.
There's another line. Get us.
But if I put it down here, then there's too much space between those two.
I was wondering if you knew. That's all.
It's funny that like all of us can figure it out, but for some reason you just can't get it on the line.
Why does it matter?
Because.
So,
Good lord. Have you guys been talking about this for like a long time?
Yeah, all year.
Alright. Anyway.
I don't notice it because I can't see it. So
I'm just gonna wait till my senior year to talk about it.
feels my
Alright, whatever. So, integral the left-hand side, and you get negative 1 natural log, and then I'm just going to resubstitute the u back in, and it's 200 minus y plus c. Now you can subtract the c's from both sides, and when you subtract c from c, it's, guess what? C. I know you guys love that. It's what? It does. Then, when you subtract c from both sides, you get c on the right-hand side. And then you should also multiply both sides by negative 1. And so this becomes negative kx plus c. Even though you multiplied it by negative 1, it's still plus c because we don't know what c is. So we might as well still just call it plus c. This is natural log of 200 minus y. And now how do we undo natural log? E to that power, right? So we're going to do, when we do e to the natural log power, it undoes the natural log, and we're left with 200 minus y equal to, and then this is e to the negative kx plus c. But I can split this up into two different e exponents, I can make it e to the c times e to the negative kx equal to 200 minus y. And guess what e to the c really is? C. Our good old buddy, just hanging out. And this is equal to 200 minus y. Now I got to get 200 onto the other side. So I'm going to minus 200 from both sides. So I'm going to get negative y is equal to c times e to the negative kx minus 200. And then I have to multiply both sides by negative 1. And I'll get y is equal to, now when you multiply this first term by negative 1, the c absorbs the negative 1. And guess what it turns it into? C.
What if I said it was negative c?
You can, if you want to. There's no consequence. You could even change it to another constant if you wanted to.
C over 2?
Sure. You could call it h. You could call it q. Whatever you wanted to. It's just a constant.
No,
I'm gonna okay.
I'm gonna start putting these like weird.
Okay, I'll change my y to
Sure.
t, my c.
No, don't do that.
No, hear me out. So y will become t, c will become r, e will become a.
Don't do that.
Become s.
You don't get to do
X
that.
will be h.
You don't get to change Euler's.
So
Okay,
trash for sure.
quiet. Back to this. Now, we have two constants that we need to figure out now. We need to figure out what C and what K are. In order to do that, we're going to use the fact that after 1 month they sold 20,000, and also at 0 months, before they even introduced the phone, how many phones did they sell?
0.
Okay. So y of 0 will be equal to 0. So at time 0, y was 0. So I'm going to put 0 in for y. C times e to the negative k times 0. This is x, I guess. Plus 200. So this is e to the 0 power, which is 1. So this is c plus 200 equals 0. So what would c have to be equal to?
Negative 200.
So c is negative 200. So there's one constant out of the way. I'm going to need to flip my paper here in a second. You guys ready to brace yourselves?
I don't like where it's going. Where'd you get that?
Probably true, and yeah.
You know, I feel like we
You would have put it on the page.
Look. Look how respectful I have been since you brought it up.
But you like missed those two. Like those two.
I give her that right. He's making change. He's trying.
Okay,
You're a new robot.
all right. So we know that C is negative 200. Now, we're going to use 1 month, 20,000 phones to find out what K is. You guys ready for me to flip? Okay. So, right now our equation is y equal to negative 200 in place of c times e to the negative kx plus 200. But I know that y of 1 is equal to 20. I'm using 20. You might be using 20,000 because you love your zeros. In which case, I wouldn't want to take anything away from you. Love your zeros as much as you love your zeros. Because it says after 1 month, sorry, you can't see that. After 1 month, they've sold 20,000. So
20,000 equals.
So I'm going to use 20 because I locked off those zeros. So I'm going to say, I'm even going to write it on the next line. I'm not going to skip that line, despite how jammed up against the y it's going to be. 20. Look how crammed up against that y that is.
You just slide it over left.
Look how crammed up against the y. Negative 200. If I skipped a line,
skip the line
When
what?
you skip lines, you like do it in the middle of the line and then go up into the other line. Like it's just not even right.
Okay. So now I need to solve for k. So I'm going to subtract 200 from both sides. So this is going to be negative 180 equal to negative 200 times e to the negative k, because negative k times 1 is negative k. Now, what do I need to do to get the negative 200 on the other side? No. No. Divide both sides by.
Negative 200.
Okay, and negative 180 divided by negative 200 is. Use your robot buddies if you need to.
Like 1/9.
No.
9/10.
Yes,
Okay.
9/10. That's e to the negative k. Now, how do we solve e to the negative k equals to 0.9?
Yeah, put in the natural log.
Natural log. So natural log of 0.9 is equal to negative k. Natural log of 0.9, we're going to round that to 4 decimal places, which is negative 0.1053, 4 decimal places, is equal to negative k. And so plain old k is 0.1053. And so we have our real equation now. Y equals negative 200 e to the negative 0.1053x plus 200. So if you want to find out how many phones they've sold after 9 months, you just take that equation, type it into your calculator, be cautious about your parentheses, especially with the exponent of e, and put 9 in place of x. And that'll tell you how many phones they've sold after.
And multiply by 1,000.
For me, yes. If you love your zeros and you did not lop those zeros off, no. I lopped off the zeros, so I would need to multiply my answer by 1,000. If you did not lop off your zeros, because it sounds like some of you didn't lop off your zeros. Yes.
So you just multiply by 1,000.
For me, yeah. You said you weren't going to lop off your zeros.
Yeah, but then you did because I know that you had to go back and bring it.
I kept mine with all the zeros. It just
Okay.
took me longer.
Yes, you can. Hop along like the wind.
Wait, oh, so that's equal to
Wait,
negative
what am I
k.
plugging for x?
9.
I'm really confused
Because it's asking.
about this.
Okay.
How long are we gonna like go over this? Like,
I'm planning on like differential equations and carrying capacity and all of these different applications of it. This is going to be like an entire chapter.
What did
okay,
you
but
get?
we're gonna like keep going over this.
Oh,
in class.
yeah.
Okay.
What did you get for your answer?
It should be 122,000 phones.
473.
No, it's not. They can only sell 150,000 phones total.
200,000.
No. Oh yeah, 200,000 phones total.
Wait, is that the answer going with them?
I
Yeah.
said 122,473.
Yeah. Yes. Yes.
What?
I didn't round that far. It's just 122,000 something.
122.
1,000.
473.
Yes. If you round, it's 122,474 phones. But yeah.
I got 122,473.
But if you round, it's 4.
74.
Well, I got 149. Did you multiply it by 1,000?
Are your parentheses in the right place? Are your parentheses?
149,530.
Are your parentheses in the right place?
I don't know where my head is.
122 down to 4, 7, 4. Boom. Okay, yeah, celebration over. That took 19 steps.
It's big boy math, dude.
Of course, I have steps 1, 2, 3, 4, and then I'm like 5, 6.
What?
Put in your decimal one, that's what you got the answer. Decimal, that's the E is the
Right, that's on a calculator, right? Right.
1.156.
Yeah. Yeah, sure.
I'm just gonna hit enter because that was a nightmare and a half.